All right, this is our review for the MAC 1105 Test 3. Question number 1, determine whether this function, you see the blue parabola, is increasing, decreasing, and we want to use interval notation. When you are observing these parabolas, you want to interpret them from left to right. And as we look at this parabola from left to right, we see the graph decrease, decrease, decrease until it gets to the vertex. That vertex, we observe the x-axis to determine that point where our graph shifts and starts to move upward. At that point, we're at -5. So from negative infinity to -5, we see the function decreasing. And we would write that expression down here as parentheses negative infinity, comma, -5, and then we enclose -5 with brackets. From -5 to infinity, the function increases. So we describe that interval as -5 with brackets, comma, infinity. Problem 2, graph the function using the vertex, axis of symmetry, and intercept. So we want to find each of those. To find the vertex, remember vertex is the ordered pair HK, and we use our formula to find that vertex of this function. To get the h value, we divide -b by 2a. To get k, the y coordinate of that vertex, we take f of -b over 2a. So we have to find -b over 2a first. And using our given function, x squared plus 2x minus 24, we understand that our leading coefficient a is 1, our b term is 2, and our c is -24. We substitute those values into our equation to find h. B is 2, so -2 divided by 2 times a is 1, 2 times 1, we'll get -2 divided by 2, and that gives us a h coordinate of -1. So a part of our vertex, the x coordinate is -1. To get k, the y coordinate, we're going to substitute, now that we found that value of -b over 2a to be -1, we're going to substitute that value for x into our function. So we get -1 squared, that gives us 1, plus 2 times -2, or -2, and then -24. We simplify that, we'll get -25. So that is our vertex. Our vertex is at -1, -25. Next, we want to find the axis of symmetry. Now, the axis of symmetry occurs at that vertex. It's going to be the vertical line that cuts through the x-axis at -1. So we'll take our x coordinate of the vertex and write it as an equation. The axis of symmetry is x equals -1. To find the intercepts, we'll substituting again, we'll create a chart for ourselves. Remember, at every x-intercept, y equals 0, and at every y-intercept, x equals 0. So taking our given function, f of x equals x squared plus 2x minus 24, we're substituting 0 into our function for y. And remember, f of x is the same thing as y. So 0 equals our x squared plus 2x minus 24. We factor this quadratic, x minus 6 and x plus 4, set each of those factors equal to 0 and solve. And when we solve here, remember, we're going to add 6 to both sides, and over here we subtract 4 from both sides. So we get x equals 6 or x equals -4. So at both of these points, we will cross the x-axis at 6, 0, written as ordered pair, and also at -4, 0. To get our y-intercept, we substitute 0 for x. So into our given function, everywhere we have x, we substitute 0. 0 squared plus 2 times 0 equals -24. So we'll get our y value is -24. And as an ordered pair, we get 0, -24. Now we will take all of that information and graph. Remember, our vertex was given to us as -1, -25. Our vertex we plot down here, -1 and -25. Our x and y intercepts 0, -24. So we cut through the y-axis at 0, -24. Our x-intercept at -4, 0. and our x-intercept also at 6, 0. So here, when we connect those points, we'll create our graph of the function. For problem number 3, we want to determine the domain and range of this given function. Domain, remember, that refers to all of our x coordinates, and range refers to our y coordinates. If we look at this function for our domain, we're going to focus on potential x values. Since our x values are not limited, they run from negative infinity to positive infinity, we'll write our domain with parentheses, negative infinity, comma, positive infinity. The value of x is not limited. X could be any number, any real number on that number line. Now the range, when we look at the y-axis, we do have limitations. See, we have a maximum point here when y is at 6. There are not any y coordinates that are higher or larger than 6. So our range runs from values that are 6 to any numbers that are less than 6. So from negative infinity, you always want to put the smaller on the left with parentheses, comma, positive 6. We close with a bracket, okay, because our value is numbers that are 6 or any number smaller than that. For number 4, find the vertex axis of symmetry of the given function. Very similar to a previous problem. To find that vertex HK, we're going to substitute to get the H value or the X coordinate of that vertex, negative B over 2A. Using this given function, x squared plus 10x, our A value is going to be 1 of that quadratic function, and the B would be 10. You see there is no number behind 10x, so our C is going to be 0. When we substitute here, we get negative 10. Our B is 10, so negative 10 divided by 2 times 1. That simplifies to negative 5. So here is our x coordinate of the vertex. To get the y coordinate, we'll go back to our given function, f of x equals x squared plus 10x, but this time we're substituting negative 5 for x. Negative 5 squared, that gives us positive 25, plus 10 times negative 5, or negative 50. And this simplifies to be negative 25. So here our vertex is negative 5, negative 25. And for the axis of symmetry, remember the axis of symmetry will be our x coordinate written as an equation. So x equals negative 5. For number 5, write the cost equation and then answer the question. So this is a 2-part question for part A. Our cost equation is given to us based on this scenario. Business rents the truck for $33. So here's our $33 fee plus 4 cents per mile. And we're using x to represent the number of miles. So we'll write that as 0.04x. For part B, we want to find the cost for renting a truck if it's driven 450 miles. So this time we're going to substitute 450 for x into that cost equation. So where x is, we substitute 450. We want to multiply 0.04 times 450 plus 33, and we'll get the cost is $51. For number 6, are the points 4, 8 and 0, negative 8 solutions to this system? And they are. But how will we test this? We're given these two functions, y equals x squared minus 8 and y equals 4x minus 8. So we're going to go through and substitute and test each of these points, our x and y coordinates of each of those points, and determine if we get solutions to the system. All right, so when we test our points here, we'll see when we substitute into the first equation, y equals x squared minus 8, we're going to substitute that point 4, 8. We want to see if it's a solution. Y equals x squared minus 8, we're substituting 4, 8. And when we substitute, we get 4 squared or 16 minus 8. That does balance out for us. When we substitute 0, negative 8 into the second equation, we get 4 times 0, or 0 equals negative 8, and our y coordinate is negative 8, so those two balance each other out. Now we want to test our second point with the first equation, as well as our first point with that second equation. All right, so we tested one of the points with each of the equations. We just want to make sure we test both of them and confirm that we in fact get a true statement. So using that first equation, y equals x squared minus 8 again. This time we want to substitute 0 for x. So we're plugging in 0 for x, 0 squared minus 8. We want to know if that y coordinate equals -8, and it does. So this works out for the second point in the first equation. Now taking that second equation again, that y equals 4x minus 8, we want to substitute this time the 4, 8, this ordered pair, to make sure that it is also a solution to this equation. So our y is 8. We're testing to see if this is a true statement. 4 times 4, or 16, minus 8, does that give us 8? And it does. Okay, so it checks out, and we would say yes, these 2 points are solutions to the system because they are both solutions to both equations. Number 7, solve the inequality, and we want to write our solution using interval notation. Here in this given inequality, we have to distribute on both sides of this inequality. Okay, we distribute -6 times 1, we get -6. -6 times 6x, we get -36x. On the right side, 6 times 1, we get 6. And then 6 times -5x, we get -30x. Combine like terms, so we add 30x to both sides. That cancels out the 30x on the right. On the left side, -36x plus 30x, we get -6x. And then -6, we added that 6 to both sides. Cancels on the left, but 6 plus 6 gives us 12 on the right side. And then we divide both sides by -6. And remember, whenever you multiply or divide both sides of the inequality by a negative number, you have to reverse that symbol. So we had to reverse that symbol from less than to greater than. Here's our solution. X could be values that are greater than -2, but we're asked to write that solution using interval notation. Here's our interval notation. One way that we can remember to write our interval notation is by creating a number line for ourselves. So if we plot -2, values of x that are greater than -2 would be to the right. All right, and so in interval notation, we would showcase here we have an open circle because x cannot be -2, but any number that's greater than -2. We use parentheses to enclose -2, and you always use parentheses to enclose infinity, and we put a comma between them. For number 8, a projectile is thrown. After how many seconds does it reach maximum height? Here we have this situation. The ball is kicked 90 feet per second, and it's given by this height function, -16t squared plus 90t. And we want to find after how many seconds will this ball reach its maximum height, and what is the maximum height? So that's a 2-part question. To get the time that we will reach the maximum height, remember, if this ball is kicking in that upward velocity, that maximum height is going to occur at that vertex. That vertex, so we know vertex is HK, that H value, or the X coordinate, in this case is going to be our T, letter T. So to find T, or the time that it takes for us to reach that maximum height, which is at the vertex, right? We're just going to use our equation to find that H value. To find that X coordinate of the vertex, we substitute -b over 2a. And in our given function, our A term is -16, our B term is 90. We substitute those values here. We get -90 over -32. That's 2 times A, or 2 times -16 in the denominator. This simplifies to give us a time of 2.81 seconds. So for part 1, at what time will the ball reach its maximum height? It'll be 2.81 seconds. Now, what is the maximum height? Now that we know the value of H, we'll just substitute those values into our function here. Well, we know the value of T, excuse me. So if our T, our maximum T is 2.81, we go to our original function and we substitute 2.81 for T. We simplify -16 times 2.81 squared plus 90 times 2.81, and we get our maximum height at 126.56 feet. For number 9, which quantity maximizes the revenue, and what is the maximum revenue? We're given this price function and the demand equation, which is x equals negative 6p plus 600. We want to convert this to a revenue function. And when we're converting that revenue function, R, it equals x times p. Here's our value for x, negative 6p plus 600. We're given that value. So we will substitute this expression for x back into our revenue function. So right here where x is, we substitute negative 6p plus 600, which means we have to distribute. So we distribute p times both those terms in parentheses. We get r equals negative 6p squared plus 600p. And this is our function we want to work with to help us find that maximum revenue. To get the maximum revenue, again, it's going to occur at that maximum point of this quadratic function, which will be the vertex. And when we're looking at the vertex, right, remember that x coordinate of the vertex is obtained by us calculating negative b over 2a. Okay, so we'll look at our revenue equation. This is a quadratic equation, right? We have p squared. Our a term is negative 6, our b term is 600, and our c is 0. So we substitute into negative b over 2a. We get negative 600. Our b is 600 divided by 2 times negative 6. This simplifies to give us our maximum profit, which will be 50. Okay, so when will that occur? What is that x coordinate of that vertex? It will be 50. And that's your answer for part A. Now, what is the maximum revenue? Now that we know what that maximum profit or how many of those x values we have to have, which in this case is going to be 50, we'll substitute 50 for p back into our revenue function. So everywhere we have p into that revenue function, we substitute the number 50. 50 squared times that negative 6 plus 600 times 50 will give us our max revenue of 15,000. For number 10, we want to write the quadratic equation whose graph is given. In this graph, you'll notice 2 ordered pairs are highlighted for you. 0, negative 5, and the vertex, which is at 2, negative 9. We're going to use both those points to help us find A. That's the first step. We're substituting everywhere x is, we're going to plug in 0, and everywhere y is, we're going to plug in negative 5. And then for the vertex, remember the x coordinate is our h value, and the y coordinate is our k. So into our given function, this function you want to have in your notes, f of x equals a times x minus h squared plus k. For k, we substitute negative 9. For h, we substitute 2. For y, remember f of x is equal to y, we substitute negative 5. And our x is 0. And then we simplify. 0 minus 2 squared, that gives us negative 2 squared, which is 4 times a, 4a. And we have minus 9 on the end, right? Plus negative 9 gives us minus 9. When we simplify here, we're going to add 9 to both sides and divide by 4. So we add 9 to both sides. When we add 9 to the negative 5, we get 4. 4 divided by 4 will get our a term, which is 1. Now, a helps us to then write the final equation. In our final equation, we would substitute 3 values. We substitute the a term, we substitute the h, and the k. All right. So remember, our h and k comes from our vertex, which is given to us as 2, negative 9. All right, we simplify here. Our a is 1. So here for a, we substitute 1. And our h is positive 2. Our k is negative 9. And we simplify. So we have x minus 2 squared minus 9. We need to simplify this binomial expression. X minus 2 squared, we expand x minus 2, and then we distribute. You want to multiply each of those terms times each other. We get x squared minus 2x minus 2x again, and then negative 2 and negative 2, we get positive 4. Carry down the negative 9, combine like terms. This 4 minus 9 on the end, we get negative 5, and then the minus 2x and minus 2x, we get minus 4x in the end. So here's our simplified equation, and there is your review for test 3.